Greetings, algebraites. We are going to attack, kill, destroy properties of log. We're going to expand, we're going to condense, and we're also going to evaluate. Primarily, we're going to evaluate today, but before we do that, we do need to understand and use some properties of exponents first. Exponents. Because remember what log is. Exponents and log are inverses of each other. They undo each other. So the concepts in properties of exponents are going to be very similar to the properties over there. So this first one is called the product of powers. What we mean by that is that we have two powers that are multiplied together. So one of them has an exponent of m, one has an exponent of n. So what do we do? Well, the base stays the same, and what we do is we add the exponents together. We add the exponents together. So base stays the same. So let's look at a simple example. And this here would be 2 to the third times 2 to the fourth. The bases are the same. And according to the rule, the answer is 2 to the 7. I just add 3 plus 4 together. Well, where do we get that? Well, 2 cubed is 2 times 2 times 2. And 2 to the fourth is 2 times 2 times 2 times 2. So all we have to do is add that up. 1, 2, 3, 4, 5, 6, and 7. And that's what we get. So without having to expand and write out here, we can just add the exponents and be done. So the idea behind it is that we start with a multiplication situation, but we interpret that by adding. Exactly the same thing. Woo! Exactly the same thing. The product property here for log says this, that if I have a log, and it doesn't matter, I have some base b, and I have m times n here. So this now can be broken up from a multiplication situation to where log b stays the same. Log b stays the same. And what I do is I split the factors that are in there up with a sum, log base b of n. So simply put, we convert the factors into a sum and keep two separate logs. All right, now the next one over here is called the quotient of powers for exponents. And that is where we have the same base, but this time they're being divided. So I have an m here and an n here. So what happens? Well, just like up there where we added, this time we're going to subtract. So we subtract the exponents. So the quotient property here is very similar, where we start with some log with some base, and we have m divided by n. And what we do with that is that we are going to convert that into a subtraction problem. Log b of m minus log b of n. So for both situations, we have a division that becomes a subtraction. So here we have a division that becomes a subtraction. The last property that we're going to look at is called the power property. It's derived directly from here, the product property. How so? Well, if I have, instead of an n, I had an m, so m times m. That's the same thing as saying the log m plus log m. So in other words, I have two of these. In other words, I can now say 2 log of m. Well, that looks like this, that if I have log of some base, and I have my m to the power of some exponent, all I do, and it's nothing magical, all I do is take this a, and it now can become a coefficient. That's it. That's the whole law right there. So we'll walk through an example of that momentarily. So let's see what that looks like. If I have log, and we'll just use the common log here, of 2 to the third power. The rule simply says this exponent can become the coefficient, so it's 3 log of 2. Now, if I were to break it up a little bit using my earlier rule, like so, this now becomes log of 2 plus log of 2 plus log of 2. So how many of these do we have? I have 1, 2, and 3. So in other words, 3 logs of 2. So I don't need to write any of this down here. I just use my super secret rule. Now we're going to use the properties of log, and we are going to rewrite the expressions, these expressions here, in terms of log 2 and log 7. Why might we need this? Well, if we had one of those very simple calculators that only had, a few of the numbers, 1, 2, 3, 4, 5, etc., and plus and minus, but it wasn't scientific, it didn't have log, it didn't have it didn't have exponents, etc. Well, then, given this basic information here, we would be able to use this simple calculator to calculate out. So, what we have to do is take this right here, or this one here, or this one here, and this one here, and write it in terms of 2 and 7. Because we know what log 2 is, it's 0.301, and we know what log 7 is, 0.845. So this first one right here, log 4. Well, how can I rewrite that? Well, notice I need to think about it in terms of 2's and 7's. Well, it is a 2, and it's squared. So according to my exponent property there, all I have to do is put that 2 in the front, like so. And now, I'm going to say approximate equal to 0.301. I'm substituting in, and now I can, even without a calculator, 0.062. And I have my result there. So how do I look at number 2? Well, again, we're always considering things in 14, or all this number here, in terms of 7 and 2, for this context. Well, 2 times 7, that's a quick one. So now, the first step, which could be done in my head, I don't need to always write every step here. And now I can split that to be log 2 plus log 7. And now when I substitute in, I get this, 845. And now I can simplify to get 1.146. All right. Now, what other example might we have? Well, this one is fairly straightforward. 3 and 4 are very similar. All we have to do is break it up as we already see it. Remember that this is a quotient rule, or the quotient property. So all I have to do is convert it now to a subtraction situation. And substitute in my decimal equivalents, and then simplify the expression. Negative 0.544. All right, now what can I do about this one? Well, this one is virtually the same as the first one, except part of it's done for me already. So now I'm going to rewrite and put the 3 as a coefficient, or negative 3. And now I can substitute 0.845 in and use my simple calculator to multiply out. Negative 2.535. And there is my answer. Now let's take a gander at some more complicated problems. I am now on page 3 of my notes, and this time, though, we are practicing, but we're going to assume, and given the information about log 3, log 4, and log 5. So instead of thinking about log 2 and 7, we're now going to put things in context with log 3, log 4, and log 5. Now, I don't have to use them all in any given context. Well, the first one's fairly straightforward, and I'll let you finish it up. But this one here, notice that it can be written as a 3 times 4. So now I have log 3, and I split this up to be plus log 4, and you can substitute from there. Well, what about something like number 8? Well, notice that the 16 is a 4 squared. So I have two changes, the 4 squared and the 5, and now I'm going to do two things. Number one, I'm going to use the division, the quotient property, and split things. So log 4, don't worry, I left the 2 out on purpose, minus log 5. Now, why did I leave that 2 out? Because there is a 2 there, but remember the rule says I can just shove it into the front here. So there we go. Now I can continue to substitute in the appropriate values and simplify. And I'll let you practice that there. Now about problem number 6 here. Well, how do I get to a decimal from there? Well, I have to, again, creatively think. I have to put things in context of 3, 4, and 5. Well, I notice that 0.8 is the same as 8 over 10. And if I reduce that, it's the same as 4 over, it's 4 over 5. Perfect, 4 over 5. So now it's log 4 divided by 5. And that splits up to be a subtraction of the two logs, and you can substitute and simplify from there. In the next video, we will look at compressing, condensing, and also expanding logarithms.